Hello, Banuri.
Sir?
Can you hear me?
Yes, sir. I have a doubt.
Yeah, tell me.
Sir, I didn't join since the past few days. Can you recap me on what you've been doing?
Okay, we did some exam questions on third chapter, like electricity, current electricity. We did some questions, exam questions.
Okay, sir.
Maybe a few topics also. Let me check. Yeah, KVL, KCL, all that. The rules.
So what is TPL? Okay, sir.
Kirchhoff's rule.
Okay.
Kirchhoff's rule. We did then some exam question. That's what we did. You want me to show those things again? Yes. Explain those again. I'm thinking to start today ray optics. Okay, let's see. Okay. In for the ray optics, we should know two things: reflection and refraction differences. So if you know reflection, what is it? What is reflection and what is refraction? What
So
is the difference? Yeah.
reflection is bouncing back of light in the same medium. Refraction is light travels from one medium to another.
Yeah. Changing medium. Now, when do we say that light is reflecting and when do we say light is refracting? Give an example.
So when light is bouncing from a mirror, we say it's reflecting, and when light is traveling from, let's say, air to glass, we can say it's refracted.
Okay, super. Very good. So first thing, further we should know reflection of light. That is, as you said, correct, bouncing of light, bouncing back or turning back of light, provided same medium. bouncing back of light. In that, like when light enters, that ray is incident ray. When light exit after reflection, there is exiting ray, there is reflection ray, reflected ray. This is your base from where it is reflecting, bouncing back. In this one, medium is same. See, this side medium is same. It is not changing. Next thing we should know, laws of reflection. Angle of incidence is equals to angle of reflection. Second one, incident ray, reflected ray, and normal ray are always in a same plane. They all are in same plane. So this is incident ray, this is normal, this is reflected. They all are in same plane. I'll make a note of it. Then shall I scroll?
Yes, sir.
Everyone?
Yes, sir.
Yes.
So now reflection from plane surfaces. If you see here, this is incident and ray, this is one incident and normal angle, that is theta. It is reflecting on the another mirror, mirror 1 and mirror 2. There are two mirrors, which is also making some angle theta, similar angle to the in M2 mirror, and which is different is like 90 minus theta, because whole is 90, obviously. The 90 minus theta will be the remaining from the normal. So plane mirror has infinitely large radius of curvature. It's actually infinite, not large. We can say it's infinite, because if you want to make a circle, this straight line will never end. Straight line of this plane mirror can never end. For whenever we are saying that concave or convex, this we can end here, circles. If we are drawing concave, that means we can end this one here. We can make circle here. like this. Means there are it is made up from two circles. Okay, so plane mirror has infinitely large radius. And it always give virtual image. It is literally inverted. Obviously, distance is same. Magnification of the distance is same. That means magnification is one. This is a common thing for plane surfaces. Let's see here. This point is also important. The direction of the incident ray is kept constant. The mirror is rotated through an angle theta about axis to the plane mirror. Then the reflected ray rotate through angle 2 theta, double the angle. See, as we are moving, because we are also moving at some angle, that angle, the theta, in the mirror, it is also theta. So we are facing that 2 theta angle. We're facing difference of 2 theta. It's similar to a distance. If you remember this type of questions you have done in 10th standard also. Like,
That again.
sorry?
So could you
Yeah.
explain that again?
Yeah, sure. Sorry. Yeah. Like, that means what? This is a simple example if I give you instead of angle. See, this is your x distance here moving from this. So obviously this will move also x distance. So totally it is moving 2x distance. If you're moving away x distance from here, this also move also x distance. So totally we are moving 2x distance. Same way, if it is at angle theta, if I keep as an angle theta, so this will also face some angle theta. So totally from here it is 2 theta.
Yes, sir.
Okay?
Yes, sir.
If you want to make a note or else you can move. These are just common points for important points for plane mirror. If you want to make a note, wait for a few seconds, few minutes, or else we can move. Okay, let's move. It same says as for distance. If you're sorry, speed. If you're moving with the v velocity away from the mirror, and image will also face opposite direction, relative image, that will be totally 2v. No need to write whole thing here. We can just take small in that same question a point. You can just add similar with the velocity. You can same thing add on the same previous point, similar with the velocity or speed. Not velocity. You can add it's the speed. Okay. Next thing, let's see explanation first. If two mirrors are inclined at the other each other, that is 90 degree, which is shown in our diagram. Okay, the previous diagram which we saw. The emerging ray is always anti-parallel to the incident ray. That is true. Say we got anti-parallel, opposite direction. It's always anti-parallel to incident ray. If it suffers one reflection from each, whatever be the angle, the same is found to be hold good for the three-plane mirror formed in the corner of the cube. So it goes with this type of formulas. No need to write all this. We'll go with the formulas. Two-plane mirror, 360 by theta. If it is even, the number of image will be n minus 1. So how many image it can form? That's what we need to find out. If we divide 360 by theta and it is odd, that is the answer. Image will be formed. But 360 by theta is even number, then n minus 1 we have to do to make it odd again. Obviously, even number, if you subtract 1, it will become odd. Mostly, see, these two things will be happening. If it is even, n minus 1. If it is odd, just n. This optics will be like for NEET, it will be 3 questions, 2 to 3 questions, and for JEE, 1 question each type. Almost every chapter will have 1 question for JEE. That is compulsory. It will be sure. So you decided like if I want all the questions or I want to choose some question. All the question means You need to study for all the chapters. If you're not sure with some chapters, that means one question gone for JE. Okay, the next, there are two types of spherical mirrors that you already know, concave and convex. For the mirror formula, 1 by F equals to 1 by V plus 1 by U. In your board exam, they'll ask derivation for this one. Derivation of this one and derivation of like mirror formula and lens maker formula. This is easy, that no need to like remember, you already know this. All of you have studied 10th standard. Obviously. Okay. To make a Newton's formula, like object distance object is kept at x1 and object image is kept at image formed at x2. So object distance, that is u plus x1 f plus x1. So it is moving from, suppose this is a mirror. This was object. Let me change color here. This was object here, and it is focus. So it is moved x1 distance. It is moved x2, image is moved, or it is moved x2 distance. Whatever distance, 1 meter, 2 meter, or moving distance, not exactly moving somewhere, but it's moving from how much far it is from focus. So your focus is your center point now. That's what we have mentioned here. F plus x1, F plus x2. So 1 by F plus x2 plus 1 by F plus x1 equals to 1 by F. So do the LCM and get me the F value. Check, are we getting same? So do this one, because like they are asking for your board exam. They asked this derivation, so it will be helpful for your deriving. Simplify, just try to simplify x1 and x2. We need to get here f square equals to x1 plus x1 x2. Come on, let's see. It seems easy, but this is actually long, lengthy. Come on, try it. Did you get it? Did you get that or not? Are you still trying?
Trying, sir.
Okay. Come on. Okay, do one thing, keep trying later because it's taking much time, I guess. You have to do quadratic equation and all that.
Yes, sir, I got.
Mm-hmm.
I got, sir.
Okay,
That's
super,
very
super. Okay, so magnification minus v by u. So we can write, substitute the same from the in the focus point, that is v minus f by f. If it is at focus, object is at focus, it will be v minus f by f. So hi by ho. Sign convention. Yeah, this also you all remember. Left side negative, right side positive. Above principal axis positive, below principal axis negative. So left side in the sense, left and right is for distance from mirror. So up and down is for height from axis. Make a note of it. Formula and sign convention. And what is the use? Let's go next. This no need draw, just for recalling. position of object. Position of object when it is between principal focus. Pole and focus, I mean. Principal focus and pole. If when it is at principal focus and pole, it will become positive value. So image will be obviously virtual because it's behind the mirror, inside the mirror. We are getting virtual image. Do you remember all these characteristics? Like 11th standard guys, you should remember because you studied just now. What about 12th? Do you remember those characteristics? Yes or no? I want you to recall those again. Once check your notebook or textbook because you don't want to spend the time on drawing all that. Just keep those properties in mind. How I wrote here, that's it enough. Okay, so object will be positive. Magnification will be positive. That means it will be more than one. Positive means virtual erected. If it is negative, it is real inverted. You'll get real inverted image and it will be highly magnified. Highly magnified. This will be magnified when it is beyond C. And again, real inverted. Except the one case between pole and focus, remaining all are real inverted image. If it is at C, it will be same size. Magnification is 1, real inverted. If it is beyond C, it is between C and F. Magnification will be diminished, smaller than 1. M will be less than 1. Diminished means less than 1. 1 means same size. More than 1 means magnified or enlarged. So again, at infinity means at focus will be, it will be highly diminished, very, very, very small. Highly, when number comes, it is either very, very small or it is very, very large. Highly magnified, so very, very large. Highly diminished is very, very small. Make a small note for it. Do you guys recall or not? Are you able to recall what are we doing now? Aditi? Are you able to recall these characteristics? Bhanuri, Laukya. What about Rituraj? And Samhita? Yes? If you can't turn on your mic, you just give thumbs up so I can understand. Yeah, yes, you are listening. If your internet is not working or something like that and you're not able to turn on, just give thumbs up. Go on, make a note of it. Okay. Others?
Yes, sir.
Okay. Fine. Yeah. Can you guys? You can't come at 6 o'clock, right? Can we start at 6 o'clock? I want to take class for more than 1 hour or 1 hour. Like you can't, right?
Sir, I come home by 5:30, so I need some time to complete the homework which is given in the college.
Okay. No problem. Fine. I'll ask some other sir. If I think so. Today some sir posted. I saw just now. Let me see. If he's not taking and our times are matching, I'll take class extended till 7:30. Okay. Because today classes are there. Okay, guys, then see you tomorrow. If possible, I'll extend the class for till 1 hour. If not, then same 6:30 to 7:10. Let's see tomorrow. I'll see. Okay. Bye, everyone.
Thank you, sir.
Okay.